In this problem, we have a boom lift with a boom length of 30 units. There's a piston that is attached to the boom at 7 units from where it is attached to the base, connecting pivot point. And this piston is attached to the base at 2 units from the connecting pivot point. Let's pretend the pivot points are at the same height above the ground. The hydraulic piston, when fully compressed, this is initial condition, is 3.5 units long. So the x piston displacement plus the 3.5 units is the length beyond the initial condition at a given point. We want to find the distance the piston needs to move to get the end of the boom arm to 12 units high from the base connecting the pivot point, and the equation for the piston displacement relative to the height. I have listed all the variables I will be using to designate the side lengths of the triangles. How do we go about solving this one? First, we can make 2 triangles out of the large boom arm triangle. These have the same shared angle at the pivot point. This means the ratio of the side lengths are the same, so the y leg over the 30 hypotenuse equals the d leg over the 7 hypotenuse of the smaller triangle. Rearranging this, we get 7 times y over 30 equals the d side length of the triangle. Now we need to solve for the leg which is designated with the letter E. We have a right triangle, which is a triangle with a 90-degree angle. So we'll use the Pythagorean theorem, which is a squared plus b squared equals c squared, rearranged to be b equals the square root of c squared minus a squared. Rearranging this to get what we are solving for, the side E, which corresponds to a or b in the Pythagorean theorem, we are left with E being equal to the displayed equation. Now onto the green piston triangle. We have a shared d side length with the boom triangle, so we can plug in the d side length into the green triangle. The base of the piston triangle really is the e side length of the previous blue triangle minus the 2 distance from the pivot point to the point where the piston is attached to the base. So we can plug in the e length into this equation and we get the displayed equation for the f length. Now we can use the Pythagorean theorem again, but this time a squared plus b squared equals c squared form. We'll be using d, f, and g, g being the piston assembly length, which is x plus 3.5. Plugging in our d and f length, we get this equation. Then if we plug the height above the pivot point of 12, we get a g length of 6.86. This is the length of the piston assembly needed to reach the height of 12 units high. To get the displacement, we need to plug in x plus 3.5 where g was. Rearranging this equation to solve for the x displacement from initial condition, we get 3.36 for the piston displacement needed to get to a height of 12 units high. Poll update. That concludes this video. Hopefully I've earned a like, share, or subscription. If you enjoyed this video, you may enjoy one of these videos as well. Let me know how I'm doing in the comments down below. Thank you for watching.